Okay, section 5.6, titled Properties of Linear Relations. Linear relations, fancy terminology, meaning that the information provided once graphed will give us a straight line. That's what linear means. This is for a relation to be linear, a constant change in the independent variable, and it results in a constant change in the dependent variable. So when we look at the values that we're going to be inputting and the values that come out, they have to change constantly, which means, well, I'll show you in the next example, but there's a constant difference between each of the values. Okay? So question A, so example 1, does the table represent a linear relation? Justify your answer. A relation between the amount of goods and services taxed, or tax charged, T dollars, and the amount of the purchase, A dollars. So here, our independent variable, A dollars, the amount of the amount of the purchase, and our dependent variable, the amount of tax, both in dollars. And here's our table. So to just quickly look at a table to determine whether it is a linear relation or not, you look at the difference between each of the values for first the independent and second the dependent variables. So if I look at the difference between our first and second terms here, which is 120 minus 60, or 60, and then our second and third, which is 180 minus 120 is equal to 60, and so on down the table. 240 minus 180 is equal to 60, and then 300 minus 240 is equal to 60. So you can see that there is a constant change. The difference between each of these terms in our independent variable list is exactly the same, and that value is 60. Okay? Now the table below is just a table to help us do those calculations. So with our first one, because we don't have any value that we can do the difference from, we cancel them out. And then our next steps are exactly what I just did above. 120, whoops, not 100. 120 minus 60 is equal to 60. 180 minus 120 is equal to 60. 240 minus 180 is equal to 60. And 300 minus 240 is equal to 60. So we can see that constant change. And we do the same in our dependent variable list as well. 6 minus 3 is equal to 3. 9 minus 6 is equal to 3. 12 minus 9 is equal to 3. And 15 minus 12 is equal to 3. So again, we have a constant change here of 3. We have a constant change here of 60. Because we have a constant change in both the independent and dependent variables. So if they're both constant, then we have a linear relation. Oops, not linear. Linear relation. Okay. Let's do B right now while it's quick and fresh in our mind. Question B, the relation between the number of bacteria in a culture, N, and time, T minutes. So here we have our time, our independent variable. What's the difference from the first value to the second value, or second to the third, and so on and so on. Oops. 20 minus 0 is 20. 40 minus 20 is 20. 60 minus 40 is 20. 80 minus 60 is 20. And 100 minus 80 is equal to 20. So here we can see there is a constant change in the independent variable. If we do the same, 2 minus 1 in our dependent variable, we see that we no longer have a constant change. Minus 16 is equal to 16. We no longer have a constant change. It makes a nice pretty pattern. Okay? It's a pretty pattern that it doubles every time, but it's not constant, right? It's not the same. So because of this being not a constant change, whoops, okay, because this is not constant, this is going to be a nonlinear relation.